Welcome to Eddie's Research. Research in the news, is it true or false? Now, for this piece of article, so obviously this is my website here, I'm going to be looking at an article that was about procrastination. So let's have a look at the article in question. So here it is. Yes, it's an old one. I tried to find things that might be interesting, so I just moved my wrong mouse. Procrastination is pretty much all in the mind. So basically it says here that the answer may be down to differences in how our brains are wired. It identified two areas of the brain that determine whether we are more likely to get on with a task or continually put it off. Researchers used a survey and scans of 264 people's brains to measure how proactive they are. Experts say the study in psychological science underlines procrastination is more about managing emotions than time. It found that sorry if I get some of these words wrong by the way, amygdala, an almond-shaped structure in the temporal side lobe, which processes our emotions and controls our motivation, was large in procrastinators. In these individuals, there were also poorer connections between the amygdala and a part of the brain called the dorsal anterior cingulate cortex, the DACC. This uses information from the amygdala and decides which action the body will take. It helps keep the person on track by blocking out competing emotions and distractions. Individuals with a larger amygdala may be more anxious about the negative consequences of an action. They tend to hesitate and put off things, says Erhan Gentz, I think, one of the study authors based at Ruhr University, Bochum. The researchers suggest that procrastinators are less able to filter out interfering emotions and distractions because the connections between the amygdala and the DACC in their brains are not as good as in proactive individuals. Professor Tim Kyle from Carleton University, Ottawa, who has been studying procrastination for the past few decades, like you do, believes it is a problem with managing emotions rather than time. This study provides psychological evidence of the problem procrastinators have with emotional control. It shows how the emotional centers of the brain can overwhelm a person's ability for self-regulation. Dr. Peikel, I'm going to call it, if it's wrong, sorry, I'm not very good with names, is optimistic about the potential for change. He said, research has already shown that mindfulness meditation is related to amygdala shrinkage, expansion of the prefrontal cortex, and a weakening of the connection between these two areas. He said this showed that changing the brain was possible. Dr. Caroline Schulte, the lead author of the study, said the brain is very responsive and can change through the lifespan. And I'm not going to read that, but that's what you can read about how to help yourself. So, I have a few things I want to look at. Firstly, up here, the survey says that 264 brain scans were performed. Now, is that value correct? Well, and this is the misleading thing with this article, they link to one piece of research. Here it is. Dr. Peikel is optimistic about the potential for change. He says research has already shown that mindfulness meditation is related to amygdala shrinkage, expansion of the prefrontal cortex, and weakening the connection of these two areas. So let's actually have a look at the paper that he's talking about. It's actually here. Here's the article if you have a while to read. Now, it is a full research paper, but it was published in 2013. Plus, it says that they only looked at 155 healthy community adults. States here, in all the details, you can read all this to your heart's content, but there it is, the 155 adults. Building on this work, we hypothesized that higher levels of dispositional mindfulness will be associated with a decreased grey matter volume in the amygdala. Okay. So this clearly isn't the study that the article is talking about. So I'll come back to this paper later on. Now, the paper that it's actually based on was written by the lead author, Dr. Caroline Schulte. And I have it. So here we are. We're in Sage Journals, Psychological Science. There's Caroline Schulte. And then there's this excerpt here. Here we measured action control in a sample of 264 healthy adults and related individual differences in action controls to variations in brain structure and resting state connectivity. So, yes, the article is correct. It was 264 brain scans. Now, on to the next question. So we're back to the article again. And it's this bit here. In these individuals, there were also poorer connection between the amygdala and a part of the brain called the dorsal anterior cingulate cortex. So here's the picture of it. So in this bit here, I'm looking at a few things. Firstly, does the dorsal anterior cingulate cortex, the DACC, use information from the amygdala and decides what action the body will take? And does it help keep the person on track by blocking out competing emotions and distractions? Also, in this picture, are those the exact locations as shown? These things here and this bit here and whatever. Well, according to research papers and even Wikipedia, which I use, as you know, as a broad reference, I don't like Wikipedia too much because basically anyone and anybody can go in, edit it, and of course, you know, there's not many people who can keep an eye on everything in there, so, you know, don't use it for your homework. It states that it's actually the DACC. It's a little d. That's a little d. As the ACC is the main part, and the D just stands for a part of it, the dorsal. So it's the anterior cingulate cortex is the main thing, and the dorsal is just a part of it. So it's partially correct with this meaning, just not with the abbreviation, but in all fairness, that's a pretty tiny thing to be at fault with, so let's just call it correct, shall we? Because, you know, a capital D and a little d, what's it going to matter in the big scheme of things? Now, does it use information from the amygdala as stated? Naturally, this I need to look at some research papers to see if it does or not. But first, Wikipedia. So here we are in the anterior cingulate cortex. Wikipedia, you can see it here. You can all click on these links. I've got them all in my article, and obviously you can see they exist. It's not just me editing something or telling you it's true because, you know. And here it is in the anatomy. The dorsal part of the ACC is connected to the prefrontal cortex and the parietal cortex, as well as the motor system and the frontal eye fields, making a central station for processing top-down and bottom-up stimuli and assigning appropriate control to other areas of the brain. By contrast, the ventral part of the ACC is connected to the amygdala, nucleus accumbens, hypothalamus, hippocampus, and anterior insula, and is involved in assessing the salience of emotion and motivational information. So the main part of that quote is that the dorsal, the DACC, is connected to the cortex. Where is it? Connected with the cortex. The motor system and the frontal eyelids. Yeah? Where is it? Frontal eye fields. But the ventral, so I'm assuming the VACC is the ventral, because of course DACC is the dorsal. So if it's not right, then fortunately that's just what I'm calling it. So I'm going to call the ventral the VACC. So the ventral is connected to the amygdala. So there's the cortex, there's the dorsal, there's the cortex, there's the frontal eye fields. And the ventral part is connected to the amygdala. the nucleus accumbens, the hypothalamus, the hippocampus, and anterior insula. So that states not the DACC, but the VACC that's actually connected to the amygdala. So I found this article. This one here, Cingulate Cortex from Science Direct. It's again, it's another one of these hefty things to have a good look at. But when you scroll down, there it is. Well, that's not it, but this is here. So the ventral anterior cingulate is part of the brain default mode network, where the dorsal anterior cingulate is a component of the frontal parietal attention networks. The ventral anterior cingulate cortex includes subcallosal and precallosal portions that have extensive connections with the insular prefrontal cortex, amygdala, hypothalamus, and brainstem. So, again, it looks like it's not the DACC as the article suggests. So that part is incorrect. So we've gone from Wikipedia to somewhere a bit more that's got some stuff, and this is where it is. And as for the part in the article that states it helps keep the person on track by blocking out competing emotions and distractions, well, that part is correct for the amygdala, as we've realised. So the next part to look at is this quote here. The individuals with a large amygdala may be more anxious about the negative consequences of an action. They tend to hesitate and put off things, says Erhan Genk, one of the study authors based at Ruhr University, Bochum. So was he actually one of the authors of the main research this article is reporting on? Well, although Dr. Peikel, I'm calling him Peikel, is mentioned in his article discussing the research he's done over the years, he wasn't one of the authors of the main study. But Erhan Genk, on the other hand, was. So if you remember, this is where we've been before. Click on the word more, and there he is, Erhan Genk, and there's Caroline Schulte. But no, I can't hover over it obviously, but no PYCHL. So that part is actually correct. Now, the next part is actually the main subject of this article. So Dr. Peikel is optimistic about the potential for change. He said research has already shown that mindfulness meditation is related to amygdala shrinkage, expansion of the prefrontal cortex, and a weakening of the connection between these two areas. Now, this is for the original research paper, as he stated above, and not for the one that this article of 264 brain scans is about. But let's see if we can check it out, see if there is a shrink in the amygdala and expansion of the prefrontal cortex. Sorry. So, let's go back to that first website. So this is the first one. Remember, this is the guy's website here. And so there's a lot of information, but I'm only actually concerned with numbers. Now, I did look through, fortunately, most of this thing. I lost my mind. But nothing in here stood out to help me on this one. You know, like I say, if you really want to, it's all there for you to read. If you've got a spare 4 years to read it. So this is the main thing, and there were some actual figures on the left. Originally, when I did my article research a while back, believe it or not, this is an oldest research thing, I could actually view these, but they've hidden up, so you've had to pay for them, which I think is kind of really sad, because the other article, which was quite old, you could view the whole thing, whereas this one you've got to pay. Which so I tried to create a little small account to access it, but unfortunately that doesn't. You've got to be from an institution, which is really kind of crappy, really. It means that nobody can read this. But luckily for me, I've got a screenshot, and here it is. I kept it. So it's quite lengthy, to say the least. But there's an equation at the bottom. If I can zoom in, if you can read it. So if that helps. It doesn't really help, does it? But there's the equation. It's P less than 0.05 over 42 equals 0.01. There was 42 regions of interest. These are your regions of interest. So 42 regions of interest. And the 0.05 is actually the alpha level. So I have found this out. For each region, does it tell me there? I can't remember. Probably not. It did say before in the context, but for each region, the table shows the correlation between the grey and white matter volume and score on the action orientation during successful performance of activities versus volatility, the AOP, scale of the action control scale. Cool 1994 is the. In fact, it tells you there. Sorry about that. Correlations were controlled for sex and age. Bonferroni correction was applied, and it tells you there. Sorry about that. I'm just reading it, and it's just there at the bottom. But if you couldn't read it, I've just read it out for you. So here we are. We've gone to this website here, and it tells you what the Bonferroni correction is. The Bonferroni correction is an adjustment made to the p-values when several dependent or independent statistical tests are being performed simultaneously on a single dataset. To perform a Bonferroni correction, divide the critical p-value, the alpha, by the number of comparisons being made. For example, if 10 hypotheses are being tested, the new critical p-value would be A divided by 10. Remember, we got 42. The statistical power of this study is then calculated based on the modified p-value. The Bonferroni correction is used to reduce the chances of obtaining false positive results, type I errors, when multiple pairwise tests are performed on a single set of data. Put simply, the probability of identifying at least one significant result due to chance increases as more hypotheses are tested. So the p-value needs to be less than or equal to 0.001 for it to be of interest. What is that? There. Sorry, put small again. There. 0.001. And looking at this table, there's only one where it's 0.000. Yeah? No, that's not right. Oh, God. I can't even read my own descriptions. Yeah, pretty sure that's right. The P is 0.000. There it is, amygdala. Sorry about that. I was on the R. We hadn't even calculated it from the R. We've gone to the R to the P. So there it is, amygdala. 0.000. Sorry about that. So for the prefrontal cortex, we need to look at another table. Again, I've got a snapshot. So here we are. And it's got the same blurb down here, same equation down here. But this time it's 0.05 over 42 and the P is 0.001, 0.000. And so in the P, the only one, it's 0.001. Where are you? I know you're on the screen somewhere. There, the cingulate cortex. So, is this the prefrontal cortex? Well, it certainly lies in the middle of the prefrontal cortex. Cordial, in medical terms, means the tail or hind part. That's not to say that it's an area located at the bottom part of the brain, but it can mean the bottom area of the prefrontal cortex, if that makes sense. So the anterior is used to describe parts of the human body with regards to anatomy. Now, without delving too deep and losing you completely, in Yeah, here we go again. Wikipedia. We can look at the Brodmann area. This has all the sections of the brain in numbers. So here we are, Brodmann area. There's loads of stuff here. And it tells you about the areas here. So you can find this, you can click on these links here and it tells you where it is. But basically this is what we're after here. The ventral anterior cingulate cortex. So it is actually at the front. Or it's in the prefrontal. So my findings in this article, if you've managed to stay awake, it's an interesting one that I've actually looked at because I don't normally do this kind of thing. I've learnt quite a bit about the human brain I never really knew about. I would say it's 50-50. Sure, they got an abbreviation wrong, partially, but they got a few other things correct. However, in the article it says that the DACC, that was the main area in question, but it's actually I'm calling it again, the VACC. So I named it to keep up with the naming convention of the DACC. It may not actually be that, but it's the ventral ACC. It also mentions that it's the shrinking of the amygdala and expansion of the prefrontal cortex. Well, from the numbers in the actual research, and by delving into some of the naming, yes, it's correct. So like I say, it's 50-50, which is a shame as I would have liked them to get certain parts of it correct. And to the fact that it's the only research paper that they've included as a direct link was not even for this article, but for a previous study, but that, I believe, is not good in this opinion. Anyway, please leave any feedback on this article, and as always, it's been a pleasure to research this one. If you've got anything you want me to research, please let me know. But I don't want to do... I don't know, I'm very open to any kind of research, as you can tell from my website. Okay, thank you for watching, and goodbye.